Hello physics students. In this video, we're going to be doing a lab analyzing a parallel circuit. Now at this point, you should have already printed out the lab sheets. You actually have to print them all out because you're doing calculations and analysis and answering questions on all the sheets. So print all of them out for this lab. The other thing I want to mention is that I'm using this video for a couple different classes, and so different classes learn different things at different times. So I may be explaining things that you already have explained, that were already explained to you in previous videos. So just be a little patient because some groups will need an explanation about what we're using. So let me bring the camera for a closer view and we'll begin our experiment. So here's the basic equipment we're going to be using, including some wires. Now I have a collection of resistors here that we're going to be making the circuit out of, and they're all like these red, green, and yellow. This is not how resistors are normally colored. I added these little pieces of plastic on here so that they could be easily identified in a classroom situation, but typically resistors, the coloring scheme looks like this. Usually they have stripes on them. This one, for example, has a brown, green, red, which I believe, if you know the code, would tell us that this resistor is approximately 1500 ohms. But I've covered those up. We're just simply going to measure. We're going to take one of each and just measure what they are. I'm going to pick some straighter ones so that they work better for the experiment. All right, so there. Now, how do I measure? I'm going to use the multimeter, right? The multimeter can be switched to be an ohm meter, a voltmeter, or an ammeter. So I'm going to switch it to measure ohms, and this is the setting that I'm going to use. And then I'm going to use a couple wires that are banana plug wires and alligator clip wires. So that's what they're called. I'm going to plug in one into here and then another one into where it says temp ohm volt. And now this is configured into an ohm meter. Okay, so what I'm going to do is measure the green resistor first. I'll just clip on here both sides and I'll get a resistance value of 466 ohms or 465, as you could see. I'm going to write that down in my data table, but remember, as always, all year you're getting your own data, so you're going to go onto the Google stream and look up what your resistor value data is. 465, notice I already put the ohm unit there for you so that you don't lose credit on the lab there. So there's resistor 1, and then I'll just go ahead and measure the others. The yellow one, same thing, I just clip on both sides, and it will tell me, well, this alligator clip is not being cooperative. Okay, a little loose. And this one is about 553, as you could see. So I'm going to write my 553 value on my data table. You'll be getting your own, okay? And the last one, the red, I will clip on. And the meter is going to measure the resistance inside that little red plastic, 676. So I will write 676 right there. Okay. So there's my resistance. There are my resistor values. So I'll unclip these now, and I'll set this meter aside for a bit, and maybe move this over. Now what I'm going to do is basically go through these calculations. So here it says connect your resistors in parallel by plugging them into the proto board. See the diagram on the projector screen, which I'll just show you up close to the camera. And then calculate REQ using the formula for REQ for parallel resistors and show all work. That's right here. And then we're going to measure REQ, and then we're going to calculate a percent error. So again, some of you already know what this is. It's called a proto board, sometimes called a breadboard. The way this works, it's a little ingenious device that allows us to make circuits on the fly very easily and quickly and assemble and disassemble them. So you see these holes here that wires can plug in. So I could go like this, I plug it in there, I could plug in here. And the way these connections work is that all, let's see, 5 of these holes right here in a row are connected underneath the plastic. So if I plug any 2 wires into or any components into any two holes here, the yellow and the red are now connected underneath the board. Or I could plug in here. It doesn't matter. Anywhere in this row, those holes are connected. And that allows me to quickly assemble circuits by just plugging rather than twisting or soldering wires. So how do I make a parallel circuit? Well, this was something you would have had to figure out in class, but you're not here, so I'll figure it out for you. So what I need to do is plug these in. I'll move these out of the way for now, like this. All right. There. Now, the top ends are all connected together in that row. So all three of these, it's like I twisted the wires together. The bottom ends are all connected in this row. So they are connected in parallel. One side of each, one side of the other. That's a parallel circuit. But now I need to deliver electricity somehow from this power supply to these resistors on this plastic board. That's what these wires are for. They're called jumper wires. I'm going to plug with a banana plug wire into here, and so I'll deliver the electricity to this post, but then I use the jumper wire to bring it to the one side of the resistors there, and then the other wire is going to go in here, so I need to connect this jumper wire to the back sides of the resistors. Now I have a parallel circuit, and I could just connect from here to here, and that's those resistors in parallel. So that's how I set up the circuit. Again, you would have had to figure that out. But now I'm going to take these ohm values and I'm going to calculate this from the equation that we learned in class. So I'm going to do the calculation nicely, and then at the bottom here, I'm going to get Req equals whatever ohms, right? And then basically you'll have some number here that you calculate from formulas alone. The next thing we're going to do is we're going to measure the Req of these resistors, what they actually are. So what I'm going to do is take this ohm meter, and I could use these same wires or I could use probe wires. Maybe I'll switch to the probe wires because we're going to be using them later in the experiment. So probe wires are the ones with the sharp points. They work the same exact way as banana wires. I could use banana wires. Because, by the way, the voltages in this lab are low enough where I could touch any of these, touch any wires, I'm not going to get electrocuted. All right, so I can measure the Req simply by taking these two and connecting them to these posts like this. And there it is. I see that it's approximately 184 for my resistors, okay? So that is going to go, the Req measured right here, 184 ohms. And of course, you're going to get your own measured value from the spreadsheet that I include. This you're going to calculate from these, but this you're going to get. And then you do a percent error here, or maybe percent E, and then you get some kind of percent error. Okay, so that's that page. All right, so next we're going to set up the multimeter to measure volts, and it tells you how, but I'm not going to read it because I'm going to do it for you, obviously. And then it says to set up the rest of the circuit like this, and again, that would have been something you would have nicely had to do and problem solve and build a circuit, but that's the nature of this year. So first thing, to make this into a voltmeter, all I need to do is turn it like this, and I'm going to be going up to 12 volts, so I want to set it on the 200 volt. The 2 volt is inadequate. I'm going to too high a voltage on that setting, so I set it there. Now this is ready for volts, and then it says to set up the rest of the circuit, and so this is how I'm going to do it. Remember I said that an ammeter has to be in a circuit in series with the circuit. So I'm going to take the electricity out of the power supply. And then it doesn't matter what goes first. I could do the ammeter first, or I could do the voltmeter, the breadboard first. Let me do the ammeter first. So I put it in here, the electricity, and then it goes into this setting, and it's got to come, oh, wrong one, microamps. And then it's got to come out this one. I could use red or black, it doesn't matter. I've said this before, the wire color is just the plastic on the outside. They're all copper inside, so they work the same way. So now the electricity went through the ammeter, and I'm going to deliver it now to the resistors. Maybe I'll go like this, let's see how that looks. Yeah. still kind of small. And then after here, I'm going to send this back to the power supply. So hopefully that's clear. Maybe if I go like this, it'll show up a little bit better. But what I have is like a circle of electricity, a loop. Maybe I'll switch this with red if I have one. No, I don't have one, but hopefully it shows up well enough on the camera. So see, it comes out, loops through and goes back to the power supply, like a circle in a sense. Okay, so that's how you set up a circuit. All right, now moving on. So what I'm going to do is go on to page 2, and it says we're going to now make this 12 volts. So it's plugged in already, and what I'm going to do is take these voltage probe wires and put the voltmeter here, and momentarily I will connect them, you go on the other side, to this power supply. They're actually made for these voltmeters by doing this. You could sandwich them in place here, kind of nice. There. All right, now it's connected here, and what I'm going to do is gradually crank up the voltage until it becomes 12 volts. Doesn't have to be exact. In fact, I'm going to say 12.3 is good enough. Okay, so let me disconnect that. And record that. Right here is delta V total, 12.3 volts. Again, you're going to get your own voltage from the sheet that I've included. Let me remove this, get it a little bit out of the way, tidy things up a little bit, and slide this over like this. And now what I want to do is measure the voltage of each of the resistors independently. So the way I can do that with the voltmeter, how's that? Maybe tilt it up a little bit more. Oh, a little bit of a glare. Okay, there we are. And I'm just going to go to either side of the resistors. So like V1 is the green one. I'm going to just touch these. Oh, actually, yeah. I'm just going to touch this on this side and that side. Uh-oh, let's see. Okay, so I think I've got a bad meter here. Yeah, so I've got a loose connection. Let me switch the meters, and maybe this one will work better as an ammeter. Now you're getting the full classroom experience. This always goes wrong. People get frustrated, so maybe now you'll get the same frustration. Okay, so still not getting, oh, there we go. There it is. Okay, it was actually probably loose right there. All right, so there. All right. I'll talk about what that means in a minute, but it was blocking the current temporarily. So let's see if this one will now give us the right voltage. So there it is, the voltmeter. Is it visible? Glare. All right, something like that. All right, so what I'm going to do is touch this to the either side of the green resistor, which is resistor 1. And I see that the voltage is approximately 11.5. Okay, so let me see if this moved. Okay, it went down to 12. All right, whatever, it's good enough. That's part of the experiment. So 11.5, 11.4, yeah, 11.5. So that's what I'm going to write down for voltage resistor 1, 11.5. And I'll put the unit there. Now I want the voltage of resistor 2. So I'm going to go to either side of the yellow resistor and touch on both sides, and I get 11.5 there on the yellow one. So let me write that down. And I got that there, and I need the voltage of the third resistor, which is the red one. So I will go like this and like that, and also 11.5. Okay, so there is the voltage, the 3 voltages and the voltage of the power supply over there. The next thing that I need to do is number 5. I finished that, and it says notice the pattern, right? And you should understand why that's happening from your understanding of parallel circuits. But now we're going to do step 6, calculating the total current in the circuit using Ohm's law, use the calculated REQ, which is right here. You're going to use this and calculate the current. So you're going to do, whatever equation, I'm not going to tell you, but at the end, you're going to have the current down here that's basically calculated out. And then you're going to measure the current, which is right here. This is the ammeter measuring the current. However, it's not 64 amps. That's in milliamps. So I'll write 64.2 milliamps. And I'll let you make that conversion because this is going to give you the current in regular old amps. And this in milliamps, so you got to do conversion before you calculate your percent error. So go ahead and make all those calculations now. Okay, now next part, step 7, calculating the current through each resistor using Ohm's law. So you have enough information. You have resistor values, you have voltage values, and you're going to calculate, and in the end get I for all of these. Maybe we could do I1, I2, I3. But I just want to caution you that when you do calculations in physics class, you always have to have 3 steps. I'm not going to tell you what those are. You should know that by now. 3 steps for all of these. The other thing I want to mention is that some of these currents will be small, and a lot of times students think that you can round off small numbers. Let me give you an example. 1, 2, 1, 5 or something. Let's suppose you get an answer like this for the current. I don't know why, but so many students will just say 0.01. It's like precision no longer matters because the number's small. 0.01 and 0.012 are about 20% error right there from rounding. 20% error is bad, right? So you don't want to round. You want to have at least 3 digits in all of these. Okay, so go ahead and make those calculations now. Okay, so we're on to the next page. So it says, determine the total current in the circuit using the values you calculated in the previous step. So right here with these numbers, somehow you're going to calculate the total current with these 3 numbers, okay? Remember that in physics there are, you always have to show your steps here, all 3, and then when you're all done, you're going to have a current. And the same thing about the rounding. Don't just truncate. Leave a lot of digits. And the I measured, well, oh, this shuts off to save battery, so let's turn it back on. As we said, it was 64.2 milliamps. Again, it's still, and you still have to convert that to regular amps before you do a percent error here, and then you do the percent error. So go ahead and make those calculations now. Last step here. Step 9, predict, which means calculate what would happen to the total current in the circuit if you removed R3 from the circuit. After you predict, remove R3 and record the current using the ammeter. So do that now. Imagine what would happen if I just yank this resistor out of the circuit. What's going to happen to the ammeter reading? Again, you should have your calculation steps and have an answer here for how many amps that is. So go ahead and make that prediction now, what the total current would be with R3 removed. Okay, let's see what happens for this measured value right here. All I'm going to do is, maybe I could use this to pull this up here. Pull this up, R3, and there it is out of the circuit. There's a new current. Again, you're going to get your own value, but me, I'm doing the experiment, so I'm going to write 47.6 milliamps, which I have to then convert to regular amps to compare it to my calculation here. So get your value and then make the conversion now. Okay, the last thing is the cleanup, which you don't have to do because I'm going to do it for you. Obviously, you're not here. And then there's a couple questions, and yes, they can be really simple answers. It's a lot of every year in class you say, is that really all I have to do? And yes, you can either answer with a sentence or sentences, or just writing a formula to answer these two questions. And that's the lab. Submit photos of all 4 sheets into the Google Classroom assignment, and that's how you're going to get credit for it. So that was the Parallel Circuits lab. I hope you enjoyed the experiment. I'll see you in the next physics video.